This video we will be talking about parallel and perpendicular lines. Now in the previous video we learnt how to find the gradient of a line, and parallel and perpendicular lines are linked through the gradient. It is essential that everyone knows and understands what the words parallel and perpendicular mean. So here I have got two examples, one of which the lines are parallel, the other the lines are perpendicular. Now parallel lines are like train tracks. So they never meet and they always go alongside each other. Perpendicular lines, on the other hand, meet at right angles. They almost make a perfect cross. Okay, so in terms of a definition, parallel have the same gradient. So in terms of y equals mx plus c, parallel lines have the same gradient. So the m value on them is the same. Perpendicular lines, on the other hand, the gradients are something called negative reciprocals of each other. So what does negative reciprocal mean? The reciprocal of something, say we've got a half, the reciprocal would be 2 over 1. So we flip like a fraction. So for example, if we've got 3, that would be a third. Because 3 can be written as 3 over 1. So if you flip that fraction, you'll be left with that. But we want the negative reciprocal. So rather than just flipping the fraction, we also make it negative. So a half would become minus 2, and 3 would become minus a third. Now this is useful in the next two questions we have here. So, choose the line that is parallel to y equals 5x minus 1. If we think back to our definition about what is a parallel line, it is when the m value in y equals mx plus c is the same. So we need to find another answer that has an m value of 5. Now straight away we can see that this one is a fifth and this one is minus a fifth, so that can't be the case. These two both say 5. However, this one is negative, so it can't be that one because we only have a positive 5x. In which case our answer is C. Hopefully that will make sense. Similarly, which line is perpendicular to y equals a half x plus 1? So, notice our gradient. That's the only thing that matters here. Whenever we compare parallel and perpendicular, it's only the gradient, the m value. Now our m here is a half. We learnt previously that the perpendicular line would have a gradient of minus, and then you flip the fraction. So if we flip the fraction, it's going to be minus 2 over 1. And 2 over 1 is the same as 2. So we're looking for a gradient of minus 2. Straight away again, we have a half and minus a half. That can't be right. We find our minus 2 is here. So our answer this time is simply B. Hopefully that will make sense. Thank you very much for watching.